Here's an example, on the other hand, of what you might get if something that we classify as a predator might actually feed on not just one trophic level below, but on two trophic levels below. This is often referred to as omnivory. Something that's an omnivore, like me and you, we will feed on things that might be predators in one instance and on herbivores in another instance. Or we might even feed on plants directly. So feeding across trophic levels is one definition of omnivory. There's actually there's some nuance to that as well. So just like in the previous example of predators feeding on predators, we can ask ourselves, what is going to be the consequence of having this omnivore in a system that feeds both on these herbivores and on these plants? Okay, let's take a look at this example here, which has to do with omnivory. Now, omnivory, again, is the consumption of resources by a particular organism at two different trophic levels. So, for example, what this organism here could be doing is feeding as a predator on these herbivores, but it could also be feeding as an herbivore on these plants right here. And so this is a study by Mickey Eubanks at the Texas A&M University. He was a graduate student at the University of Maryland when he actually did this study. And he proposed that there could be two different outcomes for the herbivores based on omnivory by this particular predator. And he was working with these big-eyed bugs, Geocaris. You can see this big-eyed bug here feeding on aphids, for example. And he proposed that if the consumption of the plants actually somehow benefits and increases the abundance or the effectiveness of these predators, that this could result in bad news for the herbivores, who then are going to get nailed by these enhanced omnivores. On the other hand, what might happen is that Geocaris, or the big-eyed bug, just spends all its time feeding on plants, and therefore you've got three herbivores in the system rather than a predator in the system. So in a sense, there's a distraction of the omnivore by the plant, and these herbivores should be doing better, and they can have a bigger negative effect on plants. So he did an experiment where he actually manipulated the plants. He was working with beans, with lima beans, and Geocaris actually feeds preferentially on the pods of those beans. They pierce the bean and actually feed on the contents of the beans. And so he had treatments where he removed all the pods here, and then he had treatments with the pods here. And what you can see along the y-axis is the population size of the aphids. So these are the herbivores of the system. And then with the big-eyed bugs either present or absent. And again, when they're absent, you would expect there to be very little predation, and the aphid populations are high. On the other hand, when you add the predators, the aphid populations decline, but interestingly, they actually decline more when you had no pods on the plants. So this is consistent with that distraction hypothesis. If they're spending a lot of time feeding on the plants, then they're not spending a lot of time feeding on the aphids, and aphid populations are actually higher. They also wanted to test out the effects of having another herbivore in the system, and what they used as an experimental device was putting out eggs, and they used corn earworm eggs just because they're easy to get. And they looked at what happens when you had the second herbivore present or absent, and you actually found very little effect. Maybe maybe there's a slight increase in the aphid population when there's a second herbivore present, a second prey item available to them. Maybe this again is a bit of a release, but not that much, not compared to having the plants or not. They also looked at the amount of consumption of the corn earworm eggs and the aphid when there were pods versus no pods available. And what they found again was that consumption was much higher in the absence of those bean pods that the Geocaris really loves, compared to the condition where there were pods available. And you see this here both with the pea aphids and with the corn earworm. And this is kind of a functional response experiment where they changed the density of corn earworm and looked at consumption rates here. So here you can kind of see the saturating response in the presence of pods. I'm sorry, the saturating response in the absence of pods, and kind of mostly a flat response in the presence of pods. So again, big-eyed bug was sensitive to density, but it really did most of its consumption of these two herbivores here when it had no choice, when the plants were not around. And when you added the plant resource, the pods, then actually consumption dropped off significantly. So this is an example, at least here in these kind of short-term experiments, where having omnivory occurring actually releases the prey from consumption. However, they did this experiment over a larger time scale as well. So that first one was kind of short-term experiments, kind of several day, 1 week experiments. And then they said, all right, if that's true, then what we should see is these patterns playing out over time as well. And here's what they found over the course of a summer. Big-eyed bugs actually tended to be more common in areas where they allowed in fields that had bean pods available, compared to ones that did not have bean pods available here, especially later on in the season. And this is consistent with the fact that we know that these big-eyed bugs will eat the bean plants. And you see that both with the nymphs of big-eyed bugs and with the adults here. They tend to go into plots that had these that had the bean pods available to them. But interestingly, when you actually looked at in field populations over a longer term, if you looked at aphid amounts and the lepidopteran larvae that were there, like those corn earworms and other herbivores, they all tended to be more common in the plots that did not have the bean pods. This is where the big-eyed bugs are not here. So in the presence of the bean pods, you actually had a greater suppression of the prey here, here, and here. So even though these omnivores are aggregating to these plots, and we know that they like to feed on them, the net result on the other resident herbivores there was ultimately a lower abundance of them. And that's because once the omnivores, the big-eyed bugs, are in these plots, what they do is then they start feeding on the prey that are actually there. But it's something that you only see when you play it out over a longer period of time. And this might have to do with the fact that you can get more protein, and more a different carbon to nitrogen balance or carbohydrate to protein ratio when you're feeding on an herbivore compared to when you're feeding on a plant. Remember, those two numbers are really different based on some of the nutritional ecology. And also, once you get that aggregation, just by encounter rates, you're going to tend to have greater opportunity for predation to actually happen. So even though in the short term, you actually do see this herbivory by the omnivore, which should release predation on the herbivores, when you allow this to play out over a longer period of time, you actually see the opposite happening. So there is an important time dimension to the net effect of omnivory in this particular example.